Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at inverses and zero divisors. More specifically, we're looking at multiplicative inverses. To understand them, we need to look at the multiplicative identity. That's always 1 modulo n. It doesn't matter what n is, whether it's mod 2, mod 3, the multiplicative identity is 1. We call it the identity because it preserves identity. If you times 1 by a number, you don't change the identity of that number. So a multiplicative inverse, and we usually just call it an inverse for simplicity, that's a number by which you can multiply in order to get the multiplicative identity of 1. So let's look at why they're important through an example. So we're going to perform these calculations mod 20. We're going to try to calculate the inverse of 7, 9, and 4. Okay, so the multiplicative inverse, the inverse of 7 mod 20 is 3. Why is that? Because 7 times 3 is 21, so 21 is equivalent to 1 mod 20. So 7 and 3 are inverses of each other. So what that means is if you take a number and you multiply by 7 and you multiply by 3, that's equivalent to multiplying by 1. In other words, multiplying by 7 and multiplying by 3 undo each other in modulo 20. Now we have to be careful here because 7 will have a different inverse for different values of n here. So for example, the inverse of 7 is actually 7 in modulo 8 and modulo 12. Different moduli give you different inverses. So 7 inverses 3, but this only works in modulo 20. So what about the inverse of 9 modulo 20? Well, let's look at numbers that are equivalent to 1 mod 20. So 21 is equivalent to 1 mod 20, as is 41, 61, 81. We can stop there because 81 is a multiple of 9. So what do you times by 9 to get 81? You times by 9. 9 inverse is actually 9 modulo 20 because 9 times 9 is equivalent to 1 mod 20. If you times by 9 and then times by 9 again in modulo 20, that's the same as multiplying by 1. Timesing by 9 actually undoes itself if you do it again. So you might be pleased to know that inverses are unique. So 7 times 3 is equivalent to 1 mod 20. There's no other residue, no least non-negative residue that you can multiply by 7 that will also give you 1 mod 20. Similarly for 9, there's no other least non-negative residue by which you can multiply 9 to get 1 mod 20. All right, let's try and calculate the inverse of 4 mod 20. And hopefully you see here that we're going to run into a problem. So the problem is if you multiply 4 by any number, the answer is always even. 4 times 1, 4 times 2, 4 times 3, and so on. But any number equivalent to 1 mod 20, that is any number that's 1 more than a multiple of 20, is going to be odd. You can't multiply 4 by any integer and get an odd answer. Remember that decimal numbers don't exist in modular arithmetic. We can't multiply 4 by like 3.25 or something like that. So this actually has no solution. There is no multiplicative inverse of 4 modulo 20. Okay, wouldn't it be nice if we had a rule that tells us when a number has an inverse and when it doesn't? Well, fortunately, that was discovered long ago. It turns out that a number has a multiplicative inverse if and only if it's co-prime to the modulus. So if we're looking at mod 20, numbers like 7 and 9, they had a multiplicative inverse because 7 and 9 are both co-prime to 20. So we call these numbers here units. Units are the numbers modulo n that have an inverse, and they are precisely the numbers that are co-prime to the modulus. So in mod 20, the units are all the numbers that are co-prime to 20. So 1, 3, 7, 9, 11, 13, 17, and 19. Those numbers are all units modulo 20. They all have an inverse modulo 20. But all the other residues, they are not units. In fact, they turn out to be zero divisors. So what do I mean by a zero divisor? Well, I mean something you can multiply by a non-zero number to get 0. What does that mean? Well, let's look at 4 and 5. They are not units. They weren't on our list. 4 times 5 is 20, which is equivalent to 0 mod 20. So 4 and 5 are both said to be zero divisors because you can multiply them by something other than 0 to get 20. In fact, any number not on this list is a zero divisor mod 20. 10 and 2 are zero divisors because you can multiply them by something other than 0 to get 0. And you can keep going. 12 is a zero divisor because 12 times 5 is 60, and 60 is equivalent to 0 mod 20. Just so you know, 0 is never a unit. No matter what the modulo is, it is always a zero divisor. So it's worth pointing out again that whether or not something is a unit or zero divisor depends on the modulus. So 4 is a zero divisor mod 20, but 4 is a unit modulo 21 because 4 and 21 are coprime. So just because a number is a zero divisor modulo some number n, it doesn't mean it won't be a zero divisor for another value of n. And important to note is that all elements are zero divisors or units, but never both. 1 is always a unit, 0 is a zero divisor, but they can never be the opposite. 1 can never be a zero divisor, 0 can never be a unit. Because 12 is a zero divisor, there is no way it can be a unit. So, if I'm talking mod n, how many units would there be? Well, the number of units mod n is the number of elements that are coprime to n, and that is precisely given by Euler's totient function. So phi of n always tells you how many units there are modulo n. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.